This is problem 3Q from the AP Summer Packet. We have the limit as x approaches infinity of this particular rational function. Now, unfortunately, we can't just go ahead and plug in infinity because you would end up with what's known to be an infinity over infinity indeterminate form. And so unfortunately, that won't quite work out for us. So instead, another option that we can do is go ahead and try to divide by something to actually get things to cancel out. So, for example, if I was to divide this entire top, in fact, actually, let's just say if I was to multiply this by x over x, that's known to be that fufu that we've seen in the past. But instead of x over x, what if I said I have 1 over x divided by 1 over x. And that should hopefully be, to you, the exact same thing as that fufu, because 1 over x divided by 1 over x is still the same thing as doing fufu, fancy form of 1. Now, the reason why we're actually trying to do that is such that then something ends up canceling out in a moment. Now, if we look at our degrees on top, we see that it's x to the 4th. If we look at our degree on the bottom, we see that it's x cubed. Now keep in mind, the entire goal here is to get something to end up canceling or getting kind of eliminated such that we don't end up with that infinity over infinity indeterminate form. Well, in trying then to just get like the smallest thing to cancel out, I would have to actually choose, notice an x cubed is on the bottom. So maybe if I multiply that by 1 over x cubed, that x cubed would end up canceling with that x cubed. And then we don't have this bottom infinity anymore because there are no x's at all. So instead of just 1 over x, we're going to do 1 over x cubed over 1 over x cubed. I'm just going to go ahead and rewrite this so that you guys can actually see like the formal way. But that was just kind of like a little preview of why we're doing some of the things that we're doing. So we're going to multiply this entire top by 1 over x cubed over 1 over x cubed. So then we end up with the limit as x approaches infinity of x to the 4th, and pretty much actually just distributing in this 1 over x cubed. So we have 1 times x to the 4th is just x to the 4th over, on the bottom we end up with x cubed. Then the same thing happens with the negative 10. We distribute it in. Negative 10 times positive 1 is negative 10 on top over x cubed. On the bottom, the exact same thing is going to happen. We're just going to distribute. So we end up with 4x cubed times 1 is just 4x cubed all over x cubed. Same thing with this x, plus x over x cubed. And now this limit as x approaches infinity is actually the same thing as just simplifying this up a little bit. We end up with x because there are 3 on the bottom and there's 4 on top, so we're just left with 1 left over, minus 10 over x cubed. Nothing can really be canceled out there. All over. These x cubes end up just dropping, leaving us with just 4. And then there's x to the 1 on top and x cubed on the bottom. So when we cancel these, there are 2 left over. And again, those are just properties with exponents that hopefully you remember from like your algebra class. So plus 1 over x squared. Now the whole reason why we would do that is when you actually start plugging in infinity, you end up with infinity minus 10 on top, which isn't going to change because it's not a, it's not a variable. But this x will end up coming out to be infinity. And then when you cube it, it's still infinity. So this, as a result, this entire piece right here just comes out to be 0. Again, just because you have 10 on top and some huge number on the bottom, so that limit will approach 0. So really, we have infinity minus 0. all over 4 plus 1 over, same thing is going to happen here. Really, this is just infinity squared, which is just infinity. And as a result, this entire piece will just go to 0. So then as a result, that's just 1 over 0. I'm sorry, this whole thing, I should say. Sorry. This whole thing will just come out to be 0. So then we end up with infinity minus 0. That's just infinity. Because you have infinity, you're not taking away anything from it. On the bottom, you have 4 plus 0. Well, that's just still 4. And again, since infinity just keeps going on and on and on and on and on, no matter how much you divide it by, you can divide it by the larger than infinity. But as a result, you're still going to go on forever and ever and ever and up to positive infinity. So again, that would be problem 3R from the summer packet.